So this is where I got stuck last time, and I mentioned this item here in terms of to reminder to find any probability. To find any probability, all you need to ask yourself is, what are we looking for over the total, right? What am I looking for? Is there how many items do we have over the total item that we are that they've given us, okay? So in the sense, the last thing that I did not cover in terms of 10.2 is this item, the fundamental counting principle. And fundamental counting principle is basically tell you that if we have the total of each group, your K1, K2, K3, K to the N is basically how many different groups you have. If you have a total of each group, all you need to do is multiply them together, right? If, for instance, if you go to McDonald's and then they offer you 4 different burgers, 5 different kind of drink, how many ways can you order 1 burger and 1 drink? All you need to do is take the 5 burger times the 4 drink, or the 5 drink times the 4 burger, right? And then that will give you 20 items. And that's what fundamental counting principle is basically tell you to take the total of each of your group, each of your item, and multiply them together, okay? The other 2 items that I have, or that I will have, is your factorial. And the factorial is basically tell you to take that number times 1 less, times 1 less, times 1 less. If you have 2 factorial, it's basically tell you 2 times 1. If you have 3 factorial, it's basically tell you that 3 times 2 times 1, and vice versa. For any n factorial, it's basically tell you take that number times 1 less, until you go down to 1. So for instance, if we have 10 factorial, 10 explanation mark, then all you need to do is take 10 times 9 times 8 times 7 times 6 times 5 times all the way to 1. Okay, so whatever the factorial is, whatever the explanation mark is, just basically tell you take that number times 1 less, until you get down to 1. The other item I mentioned, I feel like I mentioned this item earlier, or mentioned this before our break, but the other item we have is 0 factorial will always be equal to 1, okay? And the last 2 items we have, and this is the most important thing you will see, is the permutation versus the combination. So permutation is the way that you can arrange your item, the way that you can arrange your distinguished item. And to arrange this item, this is all they ask you to do is the NPR. And I want to point out that yes, this is the formula that we have, but today we will use our calculator, and in your calculator, and hopefully your scientific calculator, whichever scientific calculator you have, they will have the built-in formula for you. And you can utilize your calculator, because you are allowed to use your calculator on your homework, on your tests, on your final exam. You can utilize your calculator to find this permutation. But in order for you to use the calculator, this is what you guys need to ask yourself is my problem, does the order matter? If the order matter, then we will use permutation. If the order does not matter, we will use a combination. And again, NPR, the N is the total item you have. The R is how many items we are choosing. Okay, so N is the total item and the R is how many we choosing. And as you can see, the combination, I will go back to this in a bit. The combination is very similar to the permutation. The only thing different is they have an extra R on the bottom, okay? The only thing different, or the main thing that you have to ask yourself is, does the order matter? If the order doesn't matter, then you use the combination, which is the NCR. If the order matter, we use the NPR. Okay, combination where the order does not matter. Permutation, that's where the order matter. And now, if let me cover this thing here, and this is the only thing we have is if we have a permutation of a distinguished item. If they tell you that we have some common number or in terms of the repeated item, and we want to put them, we want to arrange them in a distinguished order that they have nothing to be common, this is what you need to do is you take n factorial, divide by the k, time, divide by k1, k2, k to the p, in the sense that each of the k is each of the common item or a repeated item. And by the end of today, you will see the problem with this distinguished item that we have. And we will work our way through this permutation of the unlike or a like object, okay? So all of the definition, if you did Alex, you probably saw a few of this item already. Let's take a look at, or let's attack the problem. How do we know, beside the permutation, if you read the problem, they will ask you find the probability, find the probability. If they ask you find the probability, is basically what we're looking for over the total, right? Now, how do we distinguish the fundamental counting principle versus the permutation versus the combination? Okay, so one thing is if they ask you how many ways can you mix and match, how many ways can you put this item together, then those will be your fundamental counting principle. If they ask you how many ways can you choose the object from the total, for how many ways can you choose this item from the total, those will be either permutation or combination. Okay, so if we were to take a look at this problem, and I just took this problem from your item, for a dinner special at a restaurant, a customer can choose an appetizer, a salad, an entree, and a side dish and a dessert. Wow, that's a big dinner. Here is the item that you use or a customer can choose, and they ask you how many dinner special are possible. So one thing is, whenever they ask you this item, how many are possible, how many ways can you mix the item, you need to ask yourself, how many categories do I have? And in this case, hopefully you see that there are 5 different categories: your appetizer, your salad, your entree, your side dish, and your dessert, right? And then in each particular category, you need to ask yourself how many items you have. Do you agree that the appetizer you have 5, the salad you have 2, the entree you have 3, the side you have 5, and the dessert you have 3? Meaning, again, we have 5 different categories, and each category we need to know the total. Because the fundamental counting principle just tell me that if I know the total of the group, all I need to do is take each of the total and multiply them together. And that's all you need to do is take each of the category, your appetizer, multiply to the salad, multiply to the entree, multiply to the side dish, and multiply that to the dessert. And that's what fundamental counting principle is, ladies and gentlemen. And if you were to multiply this thing out, 5 times 2 is 10, 10 times 3 is 30, 30 times 5 will give you 150, and 150 times 3 should give you 450. And again, you don't have to do it by hand. Your calculator can help you. And I think in Alex, when you do the problem, do have a calculator feature in Alex that can help you. You can type it in, and then they will give you those items there. okay? But looking at this thing here, hopefully you guys see that they give you different category, and once they give you different category, that's what you need to ask yourself is at each particular category, how many options are there? And once you know the option, all you need to do is take each of the option and multiply them. Similarly to B, they ask you that we need to come up with this committee. And this committee consists of a faculty member, a student, and a female and a male student, and a parent, right? How many possible committee can we form? So in this case, do you agree that for the faculty, we have 3 faculty people? And from the student, the male student, we have 5 male students. From the female, we have 5 female students. And from the parent, we have 4. Meaning at each category, I have this total. That's my K1, K2, K3, K4. And all I need to do is I need to take this item and multiply them together. 3 times 5 times 5 times 4. 3 times 5 is 15. 15 times 5 is 15 times 5, 75. And then 75 times 4 to give you 300. So again, your calculator can help you out in terms of that item. But again, let me ask you guys a question here in terms of how to attack this problem. If they give you the total of possible item, and then from the possible item, how do you find the total mix and match item? So if you don't have question, let's take a look at this item. And if you look at this item here, and if you did the homework, you probably encountered this item already, and you probably saw how to attack it. But if you did not do it, let's take a look at how would you attack this problem. And one thing is a lot of this thing here are very similar in terms that it's worded. And you know, the main thing is you have to decipher your word. So a pizza chain wants to send out a $2 off large pizza for a subscriber on the email list. Each code contains 3 letters followed by 2 digits. The letter M, N, O, and the digit 1357 will not be used. So there are 23 letters and 6 digits that can be used. Assume that the letter and digit can be repeated. How many such coupons can we generate? So one item, one thing that I want to point out that this problem is the similar problem to this 2 problem that you have. And you will say, wait a minute, Mr. Tran, how can it be similar? How can it be similar? This one here, they give us the actual number, the actual category, the actual item, right? The reason why it's similar is, do you agree that in order for us to come up with this code, this codon, we need this, right? The code, they tell us that the code contain, each code have 3 letters and followed by 2 digits. That's what they tell us, right? That's the requirement. The requirement is they need to have 3 letters. So my L is my letter and followed by 2 digits, which is the hashtag is my digit, right? So basically everybody see that we have 3 different categories in terms of letter and 2 different categories in terms of digit, or in total, I have 5 different categories, right? Similar to example A or problem A, we have 5 categories. It's just that they give you the specific name, which is appetizer, main dish, dessert, side dish, I don't know, salad, right? This one here, we just have 5 different categories. It's just that some of the category is the same category, right? The number and the letter. So in this case, do you agree? They spell it out for us. And hopefully you guys see that how many letters can we use and how many digits can we use? Well, they spell it out that in terms of this thing here, we can only use 23 letters. So for each letter, I can only use 23 letters. And for this digit category, I can only use 6 digits. So in this case, 23 times 23 times 23 times 6 times 6, meaning the total item that I can use at the specific category is this. And if I were to use this, or if I were to take this thing here, and again, your calculator can help you out, which is 23 times 23 times 23 times 6 times 6, you will have 438,012 different category. Okay, so again, if you look at this item, this is all you do is, you basically you take this 23 times 23 times 23 times 6 times 6, right? And again, if you take that, that will be your answer, and that is your calculator, right? So, you know, your calculator will help you out. And if you have, you know, most of or some of this problem is a little bit, the number is a little bit big. So you want to have a calculator that can handle a big number. And take a look at D, and then I will pause and ask you guys if you have questions. But again, they say suppose that the license plates in certain states have 3 digits followed by 3 letters, and that's what our license plate is, right? That's our license plate is 3 digits followed by 3 letters, or 3 letters followed by 3 digits, but it's the same. The requirement, or not requirement, but the criteria that we have is the digit 4 and 5 are not used, so we cannot use the 4 and 5. So there are 26 letters and 8 digits, meaning we can use the 0, the 1, the 2, the 3, the 6, the 7, the 8, and the 9. We cannot use the 4 and the 5. And that's in total, there are 8 digits. So to attack this problem, you have to ask yourself, well, how do I come up with this license plate? How do I come up with one license plate? Well, to come up with the license plate, do you agree that I need the digit, which is the number, the digit, which is the DDD, and the L, which is the letter, right? I have 3 digits followed by 3 letters. And at the digit, how many total digits I can use? Well, I can use at the first digit, I can use 8 of them. At the second digit, I still can use 8 of them. The third digit, I still can use 8 of them. And again, the letter, how many letters can I use? I can use 26, 26, 26. And if I have this thing here, if I type in my calculator, and probably, hopefully you guys type in your calculator, because this will be a painful to do this by hand, right? And if you type in your calculator, all you type in is, again, your 8 times 8 times 8 times 26 times 26 times 26. And if you type it in correctly, this should be the number of license plates that we can generate based on this criteria, meaning 8,998,912 different license plates. And like I say, hopefully you have a calculator in hand so that you can calculate this, because I would not want any of you guys to do this by hand. I mean, if you want to challenge yourself and do it by hand, be my guest, but hopefully not, okay? But anyway, let me pause and let me ask you guys a question with C or D here. Question on why one of them I only use 23 and the other one I use 26, or question on why one of them I use 6 and the other one I use 8. Any question with this? Right? If you don't have question, let me ask you guys this question here. Let me ask you guys, if you know, it's weird. E is kind of similar to C and D, but not quite similar. The reason why, if you read this thing here, a certain train have 9 core that are being lined up on a track. One of the core is an engine, the other is a caboose. The engine will be a first core in line, and the caboose will be the last core in line. How many ways can the core be lined up? So basically, this thing here is, we go in terms of the arrangement of item, because we want to line up my core. We want to put them in some order, or the arrangement. And if you arrange something, the difference between E versus D versus C is, once you arrange it, once you line them up, you cannot line up the same core again, right? Let's say you have 9 core and you want to line them up. The first position, you have 9 choice. But the second position, you don't have 9 choice. You only have 8 choice, because one of the core is in the first position, right? Because you want to arrange, because you want to line them up, you put them in some line, meaning we cannot reuse the item that we use, right? But then on top of that, they ask you this thing here is, they want it to be specific. If you have to line this thing up, do you agree that they ask us that we need to put the engine first? And again, I put the all as a random item, right? Random call, random call, random call, random call, random call, random call. And the last position, they want the caboose, right? So as you can see, this is what the lineup that they want it to be. They want the first. Everybody see that first, they want the engine. This is where my, this is my first item. They want an engine, right? And then they want some random call, and some random call all the way into last item. They want a caboose. So everybody see that this is what I need to line them up. This is what the setup that they want it to be, something in this nature. Now, let me ask you, in terms of this thing here, do you see that I am forced? When I put this together, for my engine, I am forced, I have only one choice, is to put the engine first and the caboose last, okay? Because they only tell me that I need the engine first, and I let the caboose. Now, the random call, out of those two positions, do you agree that 9 minus the 2 position, the first and the last position, I have 9 random call left? I mean 7, so not 9. And the second item, I can pick any random call out of the 7. Once I pick it, I only have 6 left. Once I picked it, I only have 5. Once I pick, I have 4. Once I pick, I have 3, 2, and the last one, which is the random item I put here. So because they asked me to arrange it, the difference is I cannot reuse, unlike up here. You know, you say, well, what is the difference between this item and the item below? Because this thing here, we can reuse the number as we want. We can reuse the letter. That's why we have the total of 26, 26, 26, because we can reuse it. We can repeat this thing here, because you need to put them in some order, because you need to line them up in some specific item or specific way. So once you use it, you cannot reuse that item. We cannot use 7, 7, 7, 7, 7, because they have to be some in some line up that we need to put. And that's why we have to deduct 1, deduct 1, deduct 1. Okay. And again, once you can identify that, you know, the math is not difficult. Your calculator, your best friend right now, should be able to help you out, which is if you multiply this thing out, you will see that you have 5,040 different ways to arrange this thing. You are forced to use the first and you're forced to use the last. So again, in the middle, there are 5,040 different ways you can arrange this call. Okay, so you have to ask yourself, do you just choose them or do we arrange them? Is that clear? Let's take a look at this thing here. Same idea. It's weird. It's like they the hardest thing in math, right? The hardest thing in math is they give you so basic definition, and then they want you to use in that basic definition to apply to the complex problem, right? And that's what we have here, right? The basic definition we have is the fundamental counting principle. And the fundamental counting principle is basically tell you that if you know how many different categories you have, and at each category you know the total, all you need to do is multiply them together. That's your fundamental counting principle. Now, they give you this problem, and you have to determine in the way of how is your setup? What is your total of each category, or in terms of this thing here, each slot? So at the international conference, the flag for 12 different countries were displayed. Of this flag, there are 6 of them from South America, and 6 of them from the continent of Europe. The flag will be displayed in a row, alternate between the continent. A flag from South America will be first position, and in how many ways can the flag be displaced? So basically, they tell you that you need to put this flag in a alternation, right? The alternate in terms of South America, Europe, South America, Europe, South America, Europe, right? So if you were to do this thing here again, do you agree that we have 12 different slots? There are 12 different slots for this lineup of this different flag. What are the lineup? They ask us that we need to put South America first, Europe, South America, Europe, South America, Europe, South America, Europe, South America, Europe, and South America and Europe, which is the alternation of each of the flag, right? So in order to do this thing here, do you see that we have 12 different locations to put this flag in? And once again, do you agree that once you use the flag, you cannot reuse it again? Because once we use that flag, for instance, if you use Chile first, Chile is South American, right? If you use Chile first, you cannot use Chile at this location anymore because Chile is gone, right? If you use Brazil here, you cannot use Brazil again because there's only one flag for Brazil. And if you use Argentina, right? Argentina here, you cannot use Argentina anywhere else, meaning at one position, there's only one different flag. And once you use the flag, you cannot reuse it, right? Same thing with England, Germany, France, right? Something in that nature. So looking at this thing here, similar to the previous one, do you agree that the first position, you have 6 different South American flag? You choose one of them, right? Brazil, if you want to, right? And then at the second location, you have 6 European flag, but now you no longer have 6 South American flag, you only have 5, right? And again, you don't have 6 of the European, you only have 5. Basically, whatever you do, you have one less, one less, one less. And that's the difference between the previous E and F versus C and D. C and D we can reuse the item as we like, right? But D, E, and F, once you use it, is gone. We cannot put them, reuse it again. We cannot say 6 times 6 times 6 times 6 times 6 times 6, 12 times. Everybody see the difference between why we cannot use it versus we can use it, right? I mean, C and D, they tell us that we can repeat it, right? And if we can repeat, meaning we can reuse it. This thing here, they don't say that we can repeat it, but because we need to put them in some lineup, and because we arrange something, we need to, we cannot reuse the item as we have. And like I mentioned, the multiplication is easy. You know, your calculator can help you. 6 times 6 times 5 times 5 times 4 times 4 times 3 times 3 times 2 times 2 will give you 518,400 different ways that you can arrange this flag alternation of this flag. Okay. So first of all, question on how to determine, you know, the main thing is you have to determine how many slots or how many category, how many item that you have, right? And at each slot, at each category, how many item, right? How many individual item that you can put in. And once you put in, you have to ask yourself is, can I reuse it? Or do I just decrease it once I use it? Okay. And you know, I will mention when we get to the next one. But let's take a look at this particular item here. So here come the permutation versus the combination problem versus the fundamental counting principle. How do you determine that? If you remember last time, or the previous section here, not really section, but the previous problem here, they just tell you that you have a list of items and then you want to put them together. How many ways can you put them together? Okay. And if you look at this problem here, they say that you are choosing 2 objects from a group of 5 objects. So when you choose a small number from a group of bigger number, when you have to choose something from the group of something, that's when your permutation or your combination come in handy, or not handy, but those are when your permutation or your combination material will come. And how do we determine permutation versus combination? Well, in order for you to verify, or in order for you to see, you need to ask yourself is, does the order matter? If the order matter, then it will be permutation. If the order does not matter, then it's a combination. And if you look at A and B, they kind of spell it out for you, right? They ask you how many ways can this be done if the order of the choice is variant, and the other one is not variant, right? Which is not important. So look at this thing here. This is what we have, ladies and gentlemen. If the order matter, we know that is your permutation. And if your permutation, which is N, P, or, which is the N will be your total item, and the or is how many we choosing. And my advice for you guys is, if the number, if you have 2 different numbers, one is big and one is small, the smaller number will always be your or, and the N will always be your bigger number, because there is no possible way that you can choose 5 items if you have only 2, right? You can choose 2 from the group of 5, but you know, no way you can choose 5 from a group of 2. Okay, so looking at this thing here, you know, suppose you want to choose 2 objects without replacement, meaning you take it, it's gone, right? From the group of 5 objects of a pencil, eraser, a desk, a chair, and a lamp. So those are your 5 individual items. You want to choose 2 of them. You can choose a pencil and eraser, a pencil and desk, or whatever. So now they ask you how many ways can you do this if the order matter. And if the order matter, like I mentioned, will be the permutation. And the permutation here will be the n, which is 5p2. And how do we do this problem here, ladies and gentlemen? This is where you want to use your calculator. If you have the TI-83, if you have a TI-83 or 84, if you have a TI-83 or 84, it doesn't matter which one you have. Let's say if you have an 83, this is the 83 problem. Everybody see my calculator on your screen, right?
No, Mr. Train, I don't see it.
Don't see it?
I see it.
Can
I
you
see
guys
it.
see it now?
Yeah.
I see it.
All right. So if you see this calculator, which is the calculator, right? So if you have this TI-83, this is what you need to do is in order to type in 5p2, ladies and gentlemen, this is what you need to do is you need to type in 5 and you hit math. For the 83, this is what you do is you hit math and then you scroll to P or B, which is stand for probability. Everybody see that I scroll to P or B, probability. So again, and once you scroll down again, that is you hit math, you scroll over to P or B, which is stand for probability. And as you can see, option number 2, which is the NPR, the option number 3, which is the NCR, and the option number 4, which is the factorial. So we choosing the NPR, which is 5 NPR and then 2. So if you take a look at this thing here, and that's why I kind of skip over the formula itself, because your calculator can do it for you. Your calculator can do it for you. And if you have the TI-83, you can use this. And I think if on Alex, there is a calculator and they have this function in there for you. If you do the homework on Alex, there's a calculator and they have the NPR in there.